Okay. As we spoke about last time, I want to just bring up this slide to begin with about computational thinking, right? So, a few things we're going to be doing here. We're going to be doing decomposition, right? Breaking a problem down into smaller, more manageable component problems. Pattern recognition, being observant of patterns in your component problems. Abstraction, right? Ignoring details, paying attention to key features, meaning sort of a broader sense of things, right? Algorithmic thinking, meaning we're going to try to determine steps and putting them in order. And then we're going to reflect on our solutions, test for edge cases, iterate as necessary. I bring this up because we're about to talk about loops. So let's jump into, I've got loops py here. Let me go ahead and clear out my console. And I've made this new file so we can start talking about loops. Now, loops are not a completely new topic. Let me bring my, so you can see me again. Hello. Try not to block any of the code here. Loops are not a completely new topic for you, right? You've seen me code loops already a little bit in our programs for different purposes. But loops are an important structure in programming, particularly because it allows us to do a lot of things, right, in a few lines. But we can do it many, many times, right? We can do a few things many, many times, but only using a few lines of code. Let me show you what I mean. Let's for a moment pretend we had a list. We're going to say let, or not let, right? I'm thinking about different language here. We just have to say some list equals, and then let's say we wanted 50 let's do, I didn't know this works for strings, but I'd be interested to see if it works for lists. I should have tested this out, but let's test it out together. So my thinking is this is actually going to give us a list of 10 H's, but let's find out. So we're going to do Python 3 loops.py. Yeah, perfect. Notice that we have, actually it gives us a string with a whole bunch of H's in it, but that's okay. Let's go ahead and use a string. We can do that. We can actually set it up this way. Let's see how that looks. Perfect. Okay. And let's go ahead and make our list have just LO in it over and over again. And let's do it 50 times. And I'll show you why I want to do this. So we have LO, right? Okay. I want to do this because here we have a lot of letters in a string together. Let's say we wanted to do something, maybe print out each letter individually. So you could imagine a world in which the only way to accomplish this was to do print sum list 0, print sum list 1, and so on and so forth. And maybe you could get clever, command copy, command V, and now we're doing sum list 2 and sum list 3 and so on and so forth, where we're printing out this sort of vertical list of letters. Now, obviously, this is a nonsense case in terms of coding. There wouldn't be, there's no reason to be doing this at this point. But what I want you to notice is that we could theoretically do this with a long list of instructions, printing out each one. Let me present you with two issues and a problem. Issue number one, this is terrible to read, right? If I had to look at this code and it was a large program where I was doing this multiple times, I would have these huge pages of just print this, one after the other, right? This would be terrible. It's terrible to write, right? To sit here and have to write this over and over again. It introduces possibilities for errors, tons of them, right? I have to make one slip up here and all of a sudden I'm printing things either out of order or I've missed an element, right? There's lots of opportunity here for mistakes. Additionally, what if I don't know how long my string is going to be? What if I take user input and I want to print out each letter of that user input, right? So that's a potential problem. And this is where loops come in and are really nice. So We're going to start with a structure called the for in loop. Let me jump back real quickly to say a few things about loops. And let me see if I can get out of my own way here. Okay. So loops. For loops are loops that loop over a block of code based on a number of elements or a range. And specifically, a range is a type that describes the beginning and an end of a sequence, right? And sort of describes that whole sequence by sort of describing the beginning, the end, and how it iterates through that sequence, right? That's what a range is, right? So a range would be 1 to 3 containing only integers, right? Iterating by 1 each time. A continue statement in Python will skip to the end of a block in a loop and then continue on with the loop the next time through. And I'll show you that, so don't worry too much about it if you don't completely understand what I'm saying. And a break, it will break us out of the loop altogether and continue on with code after the loop. So let's try a couple of those elements. Let's, for instance, start with a for in loop. And this is like a membership operator, the in, right? The in is kind of a membership operator. So we're going to say for letter in some list, and actually in this case it's some string, right? We want to print letter. This is kind of the cleanest iteration of the for loop in the sense that we don't have to actually add an index or anything. It's just going to pick out each individual letter and run our code with that letter. So let's go ahead and now run that. And notice now we print out all of the LOLs without all of those messy print statements that we had before. I didn't have to know how long it was. It did it on its own, right? So it solved that problem. There was no mistake that was going to happen here because it literally just iterated letter by letter by letter by letter. And we did it in 2 lines of code, right? We did 50 prints in 2 lines of code. We did 100 prints, right? Because there's LO, right? There's 50 LOs, so that's 100 letters. So that's the for in loop, and that's one of the more elegant and easy ways of running a loop, particularly when you've got a set of elements. Let's, for a moment, assume that we didn't have the ability to iterate over the list of elements, or for whatever reason, we wanted to iterate in a different way. We could instead do what's called a range. So we're going to do for, and we're going to call this actually I is traditional. For I in range 0, we're going to start at 0 to some list. Now we don't want to go to some list because some list is not an endpoint of an array of a range. In this case, we want some integer. So we're going to take the length. Len is a function that gets us the length of something, and we're going to do it for the range from the range of 0 to the length of some list. And we're going to put I then as an index on some list. This will essentially do the same thing. Actually, it won't essentially. It will do the exact same thing. But what this takes in complexity, right? It's a little bit more complex than the membership, using the membership. What it increases in complexity, it also increases in flexibility, because now we can change some things about where we go, how long we go, whatnot. Let's say, for instance, I don't want to start on the first letter. I actually want to start on the second letter. So instead of going from 0 to the length of list, I'm going to go from 1. And if we go to the top of our printing, we no longer start with an L, but instead we start by printing an O. Let's say I only wanted to print the O's. I could actually add another element here, and you'll notice from my doc string that it says, okay, you want to add another element. Well, the third element, the third argument of this function, the third parameter, if you will, is what kind of steps you take through the range. So I no longer want to step by 1 each time. I instead want to step by 2. If I now run this code, I only get the O's. If I had started at 0 instead of 1, I would only get the L's. So now it's not doing every letter, it's doing every other letter indexed because it's skipping 2. So it starts off with I equaling 0. The next time it runs through its code, I equals 2. The next time it runs through its code, I equals 4, because it's adding 2 each time instead of iterating by 1. And if you don't believe me, by the way, we can always print I and see exactly how it's iterating, right? So you'll notice it goes 0, 2, 4, 6, 8, so on and so forth. Okay. What if, okay, yeah. So that's what 4 in range offers us, that level of flexibility. What if we wanted to skip over the O's in a different way? So what we're going to do is I'm going to go back to my membership one, because I think this will be clearer in that, with that structure, easier to read, which is always nice in coding. So before we said we were going to print letter. Well, what if I didn't want to print letter if the letter equaled O? Well, then I can use a conditional if letter, do my equality operator equal O, continue. So what this is going to do, there's that continue keyword I was talking about before. It's going to loop, but if letter equals O, it should skip over the print statement. And you'll notice I only get L's, right? Because when it hits that continue, it goes right to the end of the block, skipping over print and looping again. So every time it equaled O, it skipped over printing. We could also break out of it. Now, this isn't going to continue. The first time it sees an O, it's going to stop looping and then just stop the program because it's the last thing it was doing. Or if there were code after this point, it would continue that code. But it's going to break out of the loop, and thus we only get the one L because the very next letter is O, and when there's an O, we break out and we stop our loop, which are both really useful things, especially when you don't know what elements you're going to get. So, for example, if we were to take some user input, and we wanted to then iterate all over that input, right? So for letter in user input, because remember, input always returns a string to us, so we can do this again. If letter equals, let's say, space, breakout. And let me show you what this does now. So some input, we're going to type hi there and hit enter. And you'll notice hi gets printed out by the loop, but it stops after that because the space after hi causes this if statement to be triggered, and it breaks out. So if there is something we need to react to in user input, we can do it using these kind of conditionals where we say, okay, either break out a loop altogether, or maybe we say, okay, skip the rest of this loop for this piece and go on to the next one. For example, let's say we want to do some changing of strings into numbers. For letter in user input, if letter dot is let me see, is alpha, okay, which is a Boolean, meaning it's going to test if it's an alpha, if it's a letter. We're going to go ahead and continue. Oh, we've lost our connection here. Sorry about that. There we go. It's going to test if letter is an alpha, is part of the alphabet. If it is, we're going to continue. Else, we're going to print out an integer version of letter. So we know that integer of a letter of an alphabet letter A, B, C, D, right? That's going to fail. So in this code, we don't want it to fail. So we test first to see if it's part of the alphabet. If it is, we're going to continue. We're going to skip over the integer part. So let's see what happens if we do 5, 7, J, 3. Oh. Let me look at the doc string for is alpha. Oh, it's a method. Okay. I forgot the parentheses. That's a good point, by the way. If it's a function that we want to call, it has to have those parentheses after it, or a method in this case. Method, function are interchangeable. Method just means the function belongs to a class. In this case, the class of character. If it's a property, then we don't need it, meaning it's a variable associated with the class. So a variable associated with the class we call a property. We don't need the parentheses. A function associated with a class we call a method, and we need those parentheses. All right, let's see if I'm correct that was our issue. 57J3, and there you have it. 573. Okay to turn into integers. J is an alpha is part of the alphabet, so we skip over that. We continue past that. So you can see how this might be functional in terms of how we use user input. If the user was trying to enter a PIN number and there was a J in there, we could theoretically just skip over the J, keep going. If it's the right PIN number, then we get to move the user on, and they don't have to worry about the fact that they entered a letter in the middle of their numbers, and we can kind of move forward. So there's some, I mean, that's an example, but there's lots of uses where we could use these continues and these breaks. Okay, so that is writing a loop and how we use our continue statement, how we use our break statement. So that's loops for you. And one of the best things about loops is this idea that we can now write code that we can run over and over and over and over and over again without having to write it a million times. And that goes back to, if we talk about our conversation around computational thinking, as you're thinking about abstracting and finding patterns, those are really good places for loops to exist, because if we can apply the pattern over and over and over again, for instance, adding the first number. Oh, here, let's actually do that together. Let's think about the problem we were talking about with computational thinking. We have we want to know all the numbers from. So if we were doing a range, we would say number 1. Or first, let's say start number. Let's go one step further. We're going to take this as user input. So start number. I know I'm going fast here, but I think this is going to be interesting. What number should we start the sum at? Or at which number should we start the sum might be better, but so forth and so on. Okay, so that'll be a start number. Let's do end number equals input. And if you should be coding right along with me, go ahead, and I'll try to keep it relatively slow so you can keep up, but do code this with me. And just to be clear again, we're going to code the process we were just talking about with computational thinking. How do we add a range of numbers together? A Gaussian sum, if you will, right? So what number should we end the sum at? So we take these two prompts. If you remember, we need to make sure that we can turn them into integers. So we can use our try block kind of as our error handling, right? And we can say, okay, we want start number to actually be equal to the integer version of start number. We want end number to be equal to an integer version of end number. Okay. If that doesn't work, we should tell them that is not valid input, right? Okay. But assuming it does work, now we can use our algorithm to kind of do our process, right? So if we have a start number and an end number, we can find the sum of those, and we can do some multiplication. Obviously, using our algorithm, we could use our formula and our algorithm to do this without a loop, but I want to try to do it with a loop for a second. So let's make a new variable called sum that we're just going to set equal to 0. Then we're going to say for I in range, start number to end number, and we're actually going to say +1. And the reason we're going to say end number +1 is because if you remember earlier on, I told you ranges are inclusive of the first number, but they're exclusive of the last number. And we don't want it to exclude the last number. We want it to include the last number. And what we're going to do is we're going to say sum plus equals, meaning that we're going to add on to sum the sum of the, let's do I and end number minus I. So if we, let's think about this for a second. If we start at 0, the sum is going to be 0 plus whatever the end number was. Or, I'm sorry, sum is going to be the start number. So if we start at 0, or if we start at 1, let's say we're doing 1 to 200, it's going to be 1 plus, actually, this is going to be 199. Oh, no, because we're doing n number. We actually want to do n number +1 minus 1, kind of, which is strange. So let's go ahead and say we're going to have n number equal n number +1. And I'll try to explain why we're doing this. So then we can just use n number here so that we start with 1 and 201. 1 plus 201 minus 1 is 201, okay? And that gets added to our sum. The next number, which will be 2, and 200 minus 1, 199, gives us 201. And then we can do that sum over and over again. Now, again, this takes away from the beautiful multiplication we did by figuring out how many numbers there were and multiplying by those pairs, but it shows us how loops can be applied. And we'll just go ahead and print out sum. Let's see if we've done this right. This is a little bit on the fly, but that's okay. Let's start at 1. Let's end at 200 since we've already tested this. Okay, very cool. Okay. So what we've actually done here is we've ended up with 40,200. And if you remember, that's actually twice what our original solution was. So we've made a mistake. We have a bug in our code. Great opportunity for us to think through why is that bug happening and what can we do about it? Well, that bug is actually happening because I doesn't stop halfway through the range. So when we were doing our calculation, we were adding 1 and 200 all the way to the point where we got 50 plus, or 100 plus 101. But then we stopped. Our code isn't stopping there. It's continuing to do 101 and 100. And then 102 and 99. And doing all the pairs a second time. That's doubling our result. There's a number of ways we could fix that. We could certainly go in and fix the logic. A nice way of doing that, based on some of the stuff we've just already learned, is that if I equals n number divided by 2, okay, division is going to produce a float for us, and I is not going to be equal to a float. Let's try. Let's see what happens. I'll be interested to see what happens. Let's try this anyway. And in fact, let's go ahead and turn this into the int version of this. And I think what's going to happen is it's going to round it or truncate it. Oops, sorry, switched out again. But we'll see. And when that happens, if we wanted to stop our code, we can run our break. So it breaks out of the loop and doesn't continue. We're debugging in real time, and I'm not sure what the result's going to be. So let's see. So we want to start at 1. We want to end at 200. And we end up with the correct answer now. Perfect. Yeah. Because this was going to return a float, it was possible we were going to end up in this case, we were going to end up with some sort of decimal, which we really didn't want. We didn't, because the decimal was never going to be equal to the integer value of I. So instead what we've done is we've turned it back into an integer, which causes it to do what's called truncating, or essentially cutting off the decimal portion and turning it back into an integer, which for our purposes in our logic here, that comparison works perfectly for us. But again, we could have done this a number of other ways. We could have also just divided, knowing that we were always going to double our sum here, we could have just printed sum divided by 2, right? We know the logic of what our code is doing, so we can debug it by, now interestingly enough, here we've returned a float again, right? But we're getting the correct answer. We can turn it into an integer and go from there. So anyway, live debugging. What was beautiful about our algorithm is we actually didn't need a loop. We could have just done this through multiplication, but I wanted to show you how we could apply a loop to the problem we'd already talked about and how that would work out. Okay, so that is for loops. Great job.